Bonjour à tout le monde. Oui, je vais parler en anglais parce que mon français, j'ai juste prononcé ces paroles, ces mots. So, je suis I am the person that just starts in analyzing the video that Marine showed to you. And yes, it's not so easy to work on network analysis and also in social network analysis, because the measure we are using are the one that start from social network analysis in an animal like Drosophila. But there are some patterns, at least we saw some pattern using the first two video examples, and now today we'll try to show to you. So first of all, okay, social network analysis, it means analyzing social entities. Alpine marmots, for example, is a social entities. They can create groups. You can have nodes that are individual and kind of links between individuals. But is Drosophila a social animal? So we know that Drosophila is not a really social animal. But as Marine showed before, these individuals experience social learning. So they experience social information transmission, and where I will work after the video are produced is on this phase. So when naive interacting with demonstrator will somehow get the information. And we are interested if there are some structure inside the network that can predict or at least correlate with the efficiency of the information gathered. So, there are some interesting aspects that I want to introduce before going inside the social network analysis. It is quick. It means if I have a Drosophila that arrive on a flower, on a fruit, as soon as the animal is able to get information, it can acquire some benefit from the place where it is. So speed could be a way of, or a measure that we can analyze in information getting, acquisition, and eventually transmission. Then, moreover, we think, at least it has been shown, or it's supposed that information is passed by contact, by interaction among animals. And there is a recent work that starts analyzing, using network analysis for Drosophila, to understand if Drosophila have a network, a stable network, or not, because they, as we saw before, they are not social. And what they found is that individuals don't maintain a fixed position in the network, but a network, structured network, exists, and can be, and some measure of this network are repeated inside Drosophila movie, let's say, we can call it movie. They analyze some of this measure, and they propose, obviously, we know already that in social network analysis that some of this measure could be related to information flow, but today we will present some of this measure and how this measure can be evaluated in Drosophila network analysis. Okay, after the first part, we start with the second part. So we want to collect the data that arrive in this form. So they are matrix of position of individuals. And we want to get from this data interaction. It means that we ask to our software to extrapolate all the individuals that are inside a minimum threshold, a maximum threshold distance in which the animal should be so close and they will interact. And this distance will be less than 1.5 the length of the individual. And individual, to pass the information, they should stay at least for some times in contact. We don't know really exactly the time at the moment, so we are trying some different frames. For now, we are testing 10 frames. Each second is divided into 10 frames. So we say, okay, individual has to stay close, let's say for at least 1 second, but we can reduce or improve this time. I will show you the results for these 10 frames. So the code permit us to build a social matrix. But a social matrix is a matrix in which we insert on the row individual that start the interaction and on the column individual that receive. The way we decide or we think that individuals are starting an interaction is based on speed of the individual before interaction occurs. If an animal is faster, so in the same time frame walked a longer distance than the other, we say that this animal is the one that starts the interaction. As you see from the video before, there are individuals moving, touching some other individual. So we think that this could be a good way to say who is starting the interaction. So we arrive to build this social matrix, starter and receiver, number of interaction emitted, number of interaction receiver for each other. When we analyze some data, here is an example of 1 hour videos. Then I will show you example for 4 hours video also. This is the mean speed of the individual inside the video. As you can see, there is quite a variation. Some individuals are faster than others. The ones that are faster, in particular, they are not faster in the same position, just going up and down, but they are faster and they explore the highest part of the arena. The slow individual will explore few parts of the arena. There is obviously a linear relationship between utilization, distribution, and speed. So probably the probability that this animal will encounter other individuals is higher, but the probability that this animal will encounter other individuals is higher just if the other individuals are quite slow. This is a question of probability, and I will try to explain after what I mean. Here, as you can see, is it possible to build network analysis in Drosophila? This is a social network graph based on eigenvector centrality, and individual number 2, number 1, and number 7, in particular 2 and 1 also, are the faster individual in the at speed. So it seems that somehow the faster individual is the one that is more central in the network. Analyze three measures: clustering coefficients, eigenvector centrality, and betweenness centrality. I will start proposing these two because are the most used, also we saw today, and try to show how these are related with speed in Drosophila. First of all, what is if we take this animal as example and we compare this animal and its clustering and its centrality against the other two animals in the network, we can say that this animal will have a high clustering coefficient because the two nodes related to him are connected to each other. Instead, this animal has a lower clustering coefficient because he has 4 nodes, 4 edges that are connected to 4 nodes that are not connected to each other. Centrality, instead, is just a measure of taking into account how many, which is the degree of the individual inside the network. How many in degree and out degree he has, and how many in degree and out degree has the individual that are close to him. These are two important measures because some of them are really used continuously in social network analysis, for example, centrality. But is centrality a good measure for network analysis in non-social animals? This is the... So, as soon as speed of the animal increase, the centrality of an individual increase. And clustering coefficient has a completely different behavior. The faster animals are more central, but the faster animals are the ones that contact individuals that are not connected to each other. So in information transmission, what we need is not to know exactly if an animal is central inside a network. We need to know if the individual that he touch are connected to each other, because the information, as a disease or as an information, has to spread inside the network. Analyzing 4 hour videos, and because the speed of the individual can change inside the 4 hour video, we thought to calculate for each individual the mean speed at each possible interval, calculating its measure of centrality and the cluster coefficients, And we saw that also if individuals change their speed, anyway this pattern still remains. So speed is a measure related to some clusters, some network measure. But both of the two, I think, we are not interested in. What we could be interested in instead is this measure that is somehow related to cluster coefficient measure, but it's called between centrality. And this measure gives us the idea that exists in a network some individual that work as bridge of information in our case. That can be bridge of everything. Usually, I between us nodes, like this one, as the one in which the shortest path, the amount of information pass more between through this individual than through others. If I have information in this subcomponent, to reach the other subcomponent has to pass for this individual. If we look at the between centrality and the speed of the individual, we start seeing something that is more interesting. This is something that is a distribution that can be called a negative binomial distribution. The word negative binomial is really interesting too, because binomial it means or 0 or 1. And this distribution, if you see, is telling us that individual can behave strictly in two ways. I am faster, I am low between centrality. I am slow, I have high between centrality. It's not a linear relationship. It's clear that this individual will behave in a different way. So we think that between centralities and analysis with the speed of each individual during during the videos can give us at least some idea on how the information can pass. If you think that speed of individual is related to the fact that this individual maybe need information, because as quick as I am, as quick as I get information, as quick I will acquire some benefit. After a while, after 4 hours, individuals should get the information. They should somehow not reduce the velocity, the speed, but reduce the differences between speed of each individual and the betweenness. What we expect is that at first we will find a curve that is really a concavity curve that will be really steep because the differences will be higher. But as soon as the time will pass and the information will acquire, this curve will just getting closer to a linear relationship. Always negative, but closer to a linear relationship. We expect with the time, analyzing different sociometrics inside the same video, to see a shift in this curve that is based on differences in information inside each element. Moreover, this curve, again, is of particular interest because if you think at this line as a mirror, you can see that there could be some symmetry in the behavior of work speediness and centrality. If I remove the dominant from a social group and I insert a dominant, subdominant at this place, the relationship inside the group will change, the interaction and the structure of the group will change. But if I change my Drosophila fast and I make it slow, my network will remain stable. So our idea is that this curve is the one that shows the stability, that individuals are somehow in the network at the end of the time will be structural equivalence. So if I compare the number of interactions received and given in two animals in the time, they will getting closer, and they will become structural equivalence inside the network. So the time will be again a way to compare the structural equivalence of the individual, and when they will get equivalence, the information should be passed. So we expect also to see again in this kind of relationship some possibility to collect data on information transmission. To sum up, we need to know if the speed is a really good proxy. Because until we don't know if the speed is a good proxy, we cannot build all our theory. And we don't really know. It could be, but we are not sure about it. Yes, and as I told you, we should use structural equivalence, in particular between the centrality and speed, to evaluate information transmission. I want to thank you. It was a bit fast, but yes, thank you for.
Does Drosophila change place? Like they became slow Drosophila, but with I between S and some other point, they just need to pass information, and it became fast with slow speed.
Yeah, this graph that show mean velocity and cluster coefficient,
yeah,
individual change. So they can be fast sometimes in one frame and slow in another one. And as soon as they change, the relationship anyway will not change. And so it means that as soon as they stop, they will be touched from other individual.
And they became really central because the other individual gather around them because they stop moving, is it?
The more central individual are the one that has the higher degree, yeah, so the more in and out degree, yeah, at the same time. And these individuals are the ones that are faster, that move and touch the other. Okay. And that moment when they stop, they became stable, and in one interval, in that interval, this individual will start getting interaction and not giving, not so much. Their centrality will go down, but their clustering coefficient will go up.
Okay.
Because they are touched from individuals that are fast, that will touch some other individual.
Okay.
So the faster individuals are connected somehow with some other individuals, and this link will increase the clustering coefficient for the stable, the slow individual, but will decrease the centrality for the slow individual.
Okay.
The idea seems a bit particular, but the idea is in mind is that maybe information transmission follow the movement of individuals. I mean, as we were saying yesterday, as these individuals are some parties that move, touch another one, they stop, and the other one starts. So the idea is to understand at which point this information is completely passed, following the fact that some individual with their movement give movement to other individuals.
So that everybody receive the information, the pattern will slow down all over?
The idea also, but we are not sure because there are some videos which we know that they start interacting later. So we have also to wait during the video, which is the mean speed in each interval, and see how the speed of the individual are centered in this mean. So we can know who is really the faster one, not just using the mean, but center the speed in the mean inside each interval. Because in each interval you can have a big confusion or just less confusion. So we have to center the mean of the speed of one individual in the mean of that interval.
Okay.
The idea was this one.
Have you any indication, experimental indication that the number of contacts or the duration of contact has a clear influence on the positive correlation with social influence in the choice, for instance, in the selection of
one of the right medium
yes.
where to.
Because it's one of your main hypotheses of your model.
Yeah, duration indeed should be really important. The time that they spend together interacting should be really important. This time, we will try to calculate the minimum time needed. So, for example, we will try to understand if 5 or 10 frames is minimum time needed, and then calculate for how long the individuals stay in contact together. and they exchange the information. This indeed is based principally on frequencies of contact, but duration is the other sociometric we will build for each of the video. Yes, we don't have now duration, but is will be another sociometrics that will be built in parallel with frequencies of interaction. Yes.
Have you looked whether informed individuals want to share the information or not? I mean, do you observe differences in movements between informed and non-informed individuals?
No, because I didn't watch this now. I didn't watch the two differences in speed inside the same videos between naive and observed and demonstrated. But yes.
What is the assumption that do they want to share the information or they don't want to share?
There is also another theoretically another thinking on Drosophila that it's true that the one that arrived wants the information, but it's also true that the one is there at first wants to know if some information arrived. So the fact that some of them has an information does not mean that this animal does not want other information. So they will move anyway. What I expect is that the network in general will stabilize after a while, not just the single individual, but yes, also the differences between demonstrator and naive inside the same, so the difference in speed inside the same video has to be analyzed. But I don't really expect that maybe they want to exchange information, but they can have some different information also on other aspects. Maybe they are also looking for some information.
Because I think in rats, they share the information whenever they find some food which is nasty. They share this information, they go, and then the other ones will avoid this type of food. So they actively try to share this information they have.
So you expect at first, in the first part, you will find some
because what you're saying,
higher interaction or higher movement for demonstrators that maybe are trying to. Yes, it can be.
They want to share it, or I don't know, maybe.
Yes, it can be tested. Yes, it can be tested.
Because what is the expectation? You expect that they, from what you're saying, you don't expect the difference that because everyone wants information, so they're going to. But
there is another aspect. The first touch animal will get some information, but it's not maybe just because they saw that there is an information in the arena, because with the first touch, maybe they will just increase in their velocity to get that information. So it will be also interesting to see if after the first contact between naive and demonstrator, naive will start moving more, just because they have the first contact with the information to really get the information. And it will also be interesting to understand if the information if some individuals get the information at first or at the end of the videos also. And now this can influence. So if we have a lot of movement and contact at first, how this will influence the efficiency in the position. If we have some movement at the end, how this will influence the position.
Perhaps you could have different groups with different motivation. Like if you put some naive flies that have just laid, and so they are not very motivated to be looking for an oviposition site, and some that are desperate to lay their eggs, maybe you would see some differences in their behavior.
Yeah, well, some video Marine and Fred are working on are also control video. So just naive individual, no information inside the arena. To compare if anyway there is at least in the basic measure differences, and in this way, if there are, we expect that the good measure to predict information transmission will be in the real transmission phase, not in the. We expect these differences. Mani told me that also looking at the video during all the work they did in the past, she can see also differences in speaking with this. So maybe is what?
Can you make a hypothesis that social influence is not due to contact, but perhaps to the flies to smell an odor, which is diffusing in the context. And so it will not go through your contact, but you can have access to the social information or the influence.
Fred, you want to?
No, I think I mean that's more or less what mine was more or less testing when we were putting the group of rovers and seekers demonstrators, which have learned different cues. So the smell is mixed banana and strawberry, but they only learn from one source. So I think it's a double system where you need to smell. Okay, you smell banana, and oh, you're my friend, so I get the information. But you need the social sometimes.
Because in the work, I don't know if we have, in the work they were doing in 2012 on social network, they also were creating some different mutants in Drosophila, and they also suspected, they see that somehow that the contact seems to be the right way to exchange the information in these species. We are not sure anyway that it's contact, but it almost should be. Should be.
Question? Merci beaucoup, Christian.